Welcome to the next aspect of steam generation unit under the aegis of chemical process utilities. Now, before we go into the next stage, let's have a brief outlook about the topics which we covered previously. We discussed about the various components of steam generation units, in which, if you recall, that we discussed about the fuel preparation segments, we discussed about the environmental aspect, especially with the stake and other thing, and then steam generation and a power output, etc. We discussed about the various aspects of furnaces, pulverized coal system, and a draft system. In this particular lecture, we are going to discuss about the other accessories and mountings of these steam generation unit. This includes superheaters, steam temperature control, reheaters, leakage in the air heaters. So let's discuss all these things one by one. First is the superheater. This superheater usually consists of a superheater headers and superheater elements, because see, sometimes we need the steam in the superheated mode. So these superheaters are quite useful device to get the same. Now, steam from the main steam pipe, it usually arrives at the saturated steam chamber of the superheater header and is fed into the superheater element. Now, usually this superheated steam arrives back at the superheated steam chamber of the superheater header and is fed into the steam pipe to the cylinder. So, the superheated steam is a bit expensive compared to the saturated one. One of the most important accessories of a boiler is a superheater. It affects the improvement and economy of the boiler or a steam generation unit in different ways. One way is that superheater increases the capacity of the plant, because sometimes one basic example is that if you are using the saturated steam and if you are passing from one station to another station, there may be chance that the saturated steam may get condensed, thereby creating the problem of pressure drop. Because of the condensation, the volume of the segment may drastically reduced, as well as you may not get the desired effect with respect to the temperature and the pressure, and that is why the superheaters, they increases the capacity of the plant. These superheater, they eliminates the chances of corrosion in the steam turbines. They reduces the steam consumption of the steam turbine, because the higher temperature and the pressure are always desirable in the steam turbine. Now, when you see that superheaters, if they are so important, then definitely there are various type of superheaters we need to address. One is the plate superheater, another one is the pendant type of a superheater, then radiant type of a superheater, and another is the final superheaters. Apart from this, there are certain steam temperature control devices, and usually nominal control of reheat steam temperature is usually by tilting the burners, and the superheater steam temperature is usually controlled by the spraying water, because it always attributes towards the consumption and combustion aspect. So, you can control by spraying water. Now, sometimes when we talk about the control methodology according to the need, some designs are attributed to the excess air control. Sometimes you may go for the flue gas recirculation aspect, sometimes gas bypass control, control of combination superheaters, and adjustable burner controls. All these are the steam temperature control devices. Let us talk about the excess air control in superheater. The steam outlet temperature of a convective superheater, this may be increased at partial load by increasing the excess air supply. The reduced gas temperature usually decreases the furnace heat absorption for you can say the same steam production. The increased gas mass flow with its increased total heat content serves to increase the degree of superheat. Now, the steam outlet temperature of a convective superheater, this may be increased at partial load by increasing the excess air supply. Here you can see sometimes we need to go for the tempering air. Now, the reduced gas temperature, this decreases the furnace heat absorption of the same steam production. Let us talk about the flue gas recirculation. The recirculation of some percentage of combustion gas serves to control the steam temperature in the same manner as does in increase in excess air. Now, here you see that this is the flue gas recirculating fan. Now, by introducing the hot gas below the combustion zone, here you see this is the combustion zone, and if you here we are having the hot gases supply. Now, this introduction relatively increases the high efficiency. So, you can say that high efficiency can be maintained by introduction of hot gases below the combustion zone. Now, let us talk about the gas bypass control. Now, the boiler convection banks, these can be arranged in such a manner that the portion of the gas can be bypassed around the superheater elements. So, the superheater is oversized so that it will produce the required degree of a superheat at partial load conditions. Now, as the load increases, some of the flue gases are bypassed. Another important aspect is the adjustable burner control. Now, sometimes in the furnace we used multiple burner for maximizing the efficiency. So, with a multiple burner furnace, it is possible to distribute the burners over a considerable burner wall height. Now, this control is obtained by selective firing. Sometimes we use a tiltable furnace. So, the tiltable furnace may be adjusted to shift the position of the combustion zone. Reheaters. The reheater functions similar to the superheater in that it serves to elevate the steam temperature. Now, usually the primary steam is supplied to the high pressure turbine. Now, after passing through the high pressure turbine, the steam is returned to the steam generator for reheating, obviously in a reheater, after which it is sent to the low pressure turbine. Sometimes a second reheat cycle may also be provided for improvising the efficiency. Feed water heater. Now, low pressure feed water heaters are sometimes used in the condensate system between the condensate pump discharge and the boiler feed pump. So, this is the condensate pump discharge and this is the boiler feed system. So, sometimes you need to have heating so that it can maintain the appropriate temperature. Now, this by this way the utilizes the low pressure turbine extraction or auxiliary turbine exhaust system for heating the condensate. High pressure feed water heaters, they are used in feed water system between the boiler feed pump discharge and the boiler and utilize high pressure turbine extraction steam for heating the feed water. The condensate or feed water temperature increase for each feed water heater will be in the range of almost 28 to 56 degrees Celsius, with the actual value determined by turbine manufacturer's stage location of steam extraction nozzle. So, depending on the turbine size, some turbines they offer alternate number of extraction nozzles with usually a choice of using the highest pressure extraction nozzle. The selection in this particular case of a total number of feed water heater to use it should be based on the economic evaluation or economic feasibility. Let us talk about the low pressure heaters, because we are using this term in so many ways. Now, use one or more low pressure feed water heaters to raise the temperature of condensate from condensate pump discharge temperature to the deaerator inlet temperature. Now, deaerator is sometimes being used to eliminate the entrapped air in the feed water line, just because this entrapped air is having no heat value. It may cause the corrosion problem, it may cause the foaming problem, it may alter the better heat efficiency of the system. The heater drains, they are cascaded from the high pressure heater to the next low pressure heater, with the lowest pressure heater draining to the condenser. Let us talk about the high pressure heater. You may use one or more high pressure feed water heater to raise the temperature of feed water from deaerator outlet temperature to required boiler economizer inlet temperature. Now, these heater drains are cascaded from heater to heater back to the deaerator in a fashion similar to the heater drain system for the low pressure heaters. Now, there are various advantages attributed to this type of a system. One is the fuel economy. They are having the longer life, or they are the attributor of the longer life of the boiler. They are increasing the steaming capacity. So, a feed water heater is a power plant component using a preheat water delivered to the steam generating boilers. Now, the preheating of feed water reduces the irreversibilities involved in the steam generation, and therefore improves the thermodynamic efficiency of the system. Now, thereby this reduces the plant operating cost, that is maximizing the efficiency or economy, etc., and also helps to avoid the thermal shock to the boiler metal when the feed water is introduced back into the steam cycle, because it minimizes the delta T. So, that is why the chances for the thermal shock can be minimized. Now, in a steam power plant, usually modeled as a modified Rankine cycle, we have already discussed this Rankine cycle. Now, the feed water heaters allow the feed water to be brought up to the saturation temperature gradually. Now, this minimizes the inevitable irreversibilities associated with the heat transfer to the working fluid. Here we are using the working fluid, the water. Now, since we are using different cycles like Rankine cycle, Carnot cycle, etc., so let us have a brief discussion about the cycle and explanation. Now, here the energy used to heat the feed water is mostly derived from the fraction of steam extracted from the stage between the high and a low pressure steam turbine. Now, here you see this is the high and a low pressure turbine. Now, this extracted fraction should not affect the efficiency of expansion work in the turbine, which is here. The extraction fraction should be carefully optimized for maximum power plant thermal efficiency, since increasing it can cause a decrease in turbine power output. Now, this system can be explained by considering it as a two steam turbine Rankine cycle unit. Now, here we can discuss the process flow. From station 1 to station 2, the feed water is pumped from low to high pressure, and that is an isentropic process. Now, from station 2 to 3, the heating of the fluid at a constant pressure, and from 3 to 4, the heated fluid is pumped to the boiler, and that is again isentropic process. And from 4 to 5, steam formation in a boiler, that is an isobaric process. And from 5 to 6, the high pressure superheated steam expands by doing work at a very high pressure turbine generating power, that is isentropic process, partial condensation, temperature and pressure reduction. It is quite obvious because it is a turbine. Then this segment, that is 6 to 3, that is a fraction of steam is extracted for the feed water heating system at the same pressure, that is an isobaric process. And from 6 to 7 here, the low pressure steam is reheated and used to generate more power at low pressure, and that is isentropic process. And from 7 to 1, the wet vapor then passed to the condenser to condense it at constant pressure, forming the saturated liquid. Now, if we convert the entire thing into the temperature entropy diagram, and that is the Rankine cycle for 2 steam turbine unit. Now, here you see that this is the feed pump 1. So, FP1 here isentropic operation. Then it goes to here, that is the feed pump 2, and high pressure turbine. Here we are using again the isentropic operation, and a low pressure turbine, this is then isentropic operation. Now, feed water heaters can function as both open and a closed heat exchanger. Now, an open feed water heater is just a direct contact heat exchanger that allows extracted stream to mingle with the feed water. Now, because the pressure in the heater, this lies between the boiler pressure and the condenser pressure, this type of heater will often require a feed pump at both the feed intake as well as output. Deaerator is a different type of open feed water heater system. Now, this is meant to remove the non-condensable gases from the feed water along with air. So, the closed feed water heaters, they are generally shell and tube heat exchangers in which the feed water is circulated through the tubes and heated by the turbine extraction steam. Now, if we compare with the open heater, they do not require separate pumps before and after the heater to raise the feed water pressure to the pressure of the extracted steam. Now, the extracted steam, however, this must be throttled to a condenser pressure, and many power plants have a number of feed water heaters which can be open or closed. So, the feed water heaters, they are utilized in both fossil fueled or a nuclear powered plants. Small versions they are also available, and they are used to the steam locomotives, portable engines, stationary engines, etc. Now, an economizer like a feed water heater, this performs a similar goal, but in a technically distinct way. Instead of using a real cycle steam for heating, it heats the water before it reaches the boiler with the lowest temperature flue gas from the furnace. So, this is the slight difference between the superheater and the economizer. Now, this enables the heat transmission between the furnace and a feed water. So, flue gases, excess heat, economizer, and a preheating of the water. Now, when real energy content of fuel is included, the system efficiency is boosted even more. Let us talk about the air preheaters. Now, an air preheater or air heater, sometimes referred as air heater, this is general term to describe any device designed to heat air before another process. Let us take example of combustion in a boiler with the primary objective of increasing the thermal efficiency of the process. See, when we are talking about the combustion process, obviously to carry out the temperature at an optimum level, all the raw materials or all the ingredient must achieve a particular temperature zone. And if there is a drastic difference with respect to the delta T, there may be chances of a thermal shock, there may be chances of non-efficient system. So that's why the air preheater, because air is an integral part of the combustion process, so the air preheaters are quite important in any kind of steam generation unit. Sometimes they may be used alone or replace with a recuperative type of heat system, or to replace a steam coil. The purpose of the air preheater is to recover the heat from the boiler flue gas, which increases the thermal efficiency of the boiler by reducing the useful heat lost in the flue gases. Now, as a consequence, the flue gases are also sent to the flue gas stake, for example, chimney, at a lower temperature, allowing the simplified design of the ducting and the flue gas stake. It also allows control over the temperature of gases leaving the stake. This is to meet the emission regulations, etc. There are two types of air preheaters. One is the tubular type of preheater. This is built into the boiler flue gas ducting. Maybe like this, you may put over here. This is the chimney. And another is the regenerative type of a preheater. Now, these may be arranged so that the gas flows horizontally or vertically across the axis of rotation. So, it all depends on the configuration. Let us talk about the tubular type of preheaters. Now, tubular preheater, it consists of straight tube bundles which pass through the outlet ducting of the boiler and open at each end outside of the ducting. Now, inside the ducting, the hot furnace gases pass around the preheater tubes, transferring heat from the exhaust gas to the air inside the preheater. And ambient air is forced by a fan through ducting at one end of the preheater tubes, and other end of the heated air from inside of the tube. This emerges into another set of ducting which carries it to the boiler furnace for combustion purpose. There are various limitations one can talk about this tubular preheaters. Now, the tubular preheater ducting for cold and hot air, this require more space and structural support than a rotating preheater design. Further, due to dust-laden abrasive flue gases, the tubes outside the ducting wear out faster on the side facing to the gas current. Many advances have been made to eliminate this particular problem, such as the use of ceramic and hardened steel. Many new circulating fluidized bed or CFB or bubbling fluidized bed BFB type of a system or steam generators are currently incorporating tubular heat preheaters, offering an advantage with regards to the moving part of a rotary type. Another important phenomena in these steam generation unit is the dew point corrosion. Now, this dew point corrosion usually occurs for a variety of reasons. The type of fuel used, sulfur content, the moisture content, these are the contributing factors in the dew point corrosion. However, by far the most significant cause of dew point corrosion is the metal temperature of the tubes. Now, if metal temperature within the tubes drop below the acid saturation temperature, usually at between say 88 and 110 degrees Celsius, but sometimes at temperature as high as 127 degrees Celsius, then the risk of dew point corrosion damage become considerable. The regenerative type of air preheaters. Usually there are two types of regenerative air preheaters. One is the rotating plate regenerative air preheaters, and second one is the stationary plate regenerative air preheaters. Now, let us talk about the rotating plate regenerative air preheaters. Now, this rotating plate design consists of a central rotating plate element installed within a casing that is divided into two, are the bisectoral type, or three are trisector type, or a four quad sector type sectors containing the seals around the element. Here you see that that is an air inlet and a flue gas outlet, and this is the regenerative heat absorbing material. Now, this seal allows the element to rotate through all the sectors, but keep gas leakage between the sectors to a minimum, while providing the separate gas air and flue gas path through each sector. Sometimes trisector type, they are the most common in modern power generation facilities. In trisector design, the largest sector is connected to the boiler hot gas outlet. When we talk about the other integral part of rotating plate regenerative preheaters, the hot exhaust gas flows over the central element, thereby transferring some of its heat to the element and then ducted away for further treatment in dust collectors and other equipment before being expelled from the flue gas stake. The second smaller sector is usually fed with the ambient air by fan, which passes over the heated element as it rotates into the sector and heated before being carried to the boiler furnace for combustion. The third sector is the smallest one, and it heats air which is routed into the pulverizer and used to carry the coal air mixture and to the coal boiler burners. Thus, the total air heated in the air preheater provides the heating air to remove the moisture from the pulverized coal dust, first thing, and second thing is the carrier air for transporting the pulverized coal to the boiler burners, and primary air for combustion. Let us talk about the stationary plate regenerative air preheaters. The heating plate elements in this type of regenerative air preheater, they are also installed in casing, but the heating plate elements are stationary rather than rotating. Instead, we can say that air ducts in the preheater are rotated so as to alternatively expose section of the heating plate elements to the upflowing cool air. Now, here you can see the stationary plate regenerative air preheaters. This is the flue gas, this, and air is coming out. This is the top rotating air. Here you are supplying the air, and this is enclosed with the hood and the stationary section. So, there are rotating inlet air ducts are at the bottom, you can see here of the stationary plate, and similar to the rotating outlet air ducts at the top of the stationary plates. Sometimes you may experience the leakage in air heaters. Now, leakage, this is a very common phenomena or a normal phenomena in all air heaters, while leakage in a new recuperative air heater is essentially zero. Leakage occurs with the passage of time and due to accumulation of various thermal cycles. Nevertheless, leakage in a recuperative air heaters can be restricted to 3% with a regular maintenance. With the rotary regenerative type of air heaters, air leakage is inherent and its design value ranges from 5 to 10%, which increases further over time as seals wear. So, when the higher pressure air side passes to a lower pressure gas side, leakage occurs through gaps between the rotating and stationary part. Sometimes we need to calculate the rate of such leakage. So, the rate of such leakage is usually given by this particular mathematical expression: percentage of leakage, that is a percentage of oxygen leaving minus percentage of oxygen entering, divided by 21, that is the percentage of oxygen in air minus percentage of oxygen leaving, multiplied by 0.9 into 100, and WL, that is K is equal to 2g delta P rho to the power 0.5. Here g is obviously the acceleration due to the gravity, and standard norms are 9.8 meter per second square. Delta P is the pressure differential across the gap. Rho is the density of leaking air in kilogram per meter cube. So, the numerical average of the air heater's gas inlet, gas outlet and the gas inlet temperature is usually calculated, and the corrected air heater gas, that is TNL, percentage leakage into Cp into TGL minus TAE upon 100 CPG plus TGL. Now, here the TGNL is the gas outlet temperature of corrected for no leakage. TGL is the temperature of gas leaving the air heater, and TAE the temperature of air entering into the air heater. Now, when we talk about the leakage in the air heaters, we cannot overlook the importance of a gas side efficiency. Now, the gas side efficiency is usually defined as the ratio of the temperature drop corrected for leakage to the temperature head, expressed as percentage. Now, temperature drop is obtained by subtracting the corrected gas outlet temperature from the gas inlet temperature. Now, temperature head is obtained by the subtracting air inlet temperature from the gas inlet temperature, and corrected gas outlet temperature is defined as the outlet gas temperature. This calculated for no air heater leakage. So, this is the mathematical expression where the gas side efficiency GCE, referred as GCE, is equal to the temperature drop over the temperature head multiplied by 100, and sometimes TGE, that is the usual for notation, minus TGNL upon TGE minus TAE into 100. Now, here the TGE is the gas inlet which is entering, E stands for entering. So, gas inlet in temperature in degrees Celsius. X ratio. X ratio is the ratio of the heat capacity of air passing through the air heater to the heat capacity of the flue gases passing through the air heater, and is calculated by this mathematical expression. X is equal to W air out into CPA upon W air in into CPG, that is equal to TGE minus TGNL upon TGAL minus TAE, that is the temperature TGAL. Apart from other things, the TGAL, that is the temperature of air leaving in the heater, represented as in degrees Celsius. Now, because leaking is an important phenomena, so we thought that we should have one numerical problem. Now, here one numerical problem, that while evaluating the performance of a boiler, it is observed from flue gas analysis that the percentage oxygen content of the flue gas entering and leaving a rotary air heater, they are 5% and 8% respectively. So, you need to determine the percentage infiltration of ambient air. Now, in a rotary air heater whose seals are in a good condition, leakage of the air should not exceed 10%. So, the result reveals that the seal of air heater, they are in a bad shape, and a replacement and the proper adjustment of the seal should be done. Now, how we achieve this one? This is the solution, that you need to calculate the TGNL, that is GSC and X ratio, using the data which is given in the problem. So, utilize the formula, mathematical expression, that is TGNL is equal to percentage leakage into CPA into TGL minus TAE upon 100 into TPG and plus TGL. Now, if we substitute the respective values, you will find that the TGNL comes out to be 154.08 degrees Celsius, and GSE This is the mathematical expression of GSE, that is TGE minus TGNL upon TGE minus TAE multiplied by 100. So, if we are having these values, so if we substitute these values to this GCE mathematical relationship, it comes out to be 60.32. So, we can calculate the x, that is TGE minus TGNL upon TAL minus TAE, that is again we are having the different values. So, 333.5 minus 154, which we calculated earlier, upon 288 minus 36.1, it comes out to be 0.71. So, in this particular lecture, we had discussed about the various aspects attributed to the preheating system, different type of systems, superheaters, etc. And for your convenience, we have enlisted couple of references. If you wish to have a further reading, then you can utilize these references. Thank you very much.